This is lesson 8.2, properties of acids and bases. So, some common properties of acids and bases. Acids contain H+ or hydronium ions. Bases are usually things like metal oxides, hydroxides, ammonia, carbonates, or hydrogen carbonates. Alkalis are just another word for soluble bases, which means they neutralize acids to make water. Acid-base indicators are really fun because they change color according to the concentration of hydrogen ions in solution. For example, litmus paper turns pink in acid and blue in base. Methyl orange is an indicator that turns red in acid and yellow in base. And phenolphthalein is clear in acid and pink in base. A universal indicator is when several indicators are mixed together so that it changes color many times across a range of different acids and bases. In acid-base chemistry, a salt is a compound formed when the hydrogen of an acid is replaced by a metal or a positive ion. So the first really important type of reaction is when an acid reacts with metal to form a salt plus hydrogen. So think about these reactions and think about what might form as products. Well, here we have sulfuric acid and iron, and we know we're going to form a salt plus hydrogen gas. So this is going to be a single replacement where the iron replaces the hydrogen to form hydrogen gas and iron sulfate. Here we have acetic acid and magnesium, and so here we're going to form magnesium acetate and hydrogen gas. Spectator ions are species that do not change during a reaction, and they can be canceled out to give an ionic equation. For example, when hydrochloric acid, HCl, dissolves because it's a strong acid when it dissociates and is mixed with zinc, you form zinc ions and chloride ions because the zinc replaces the hydrogen to form hydrogen gas. And here we can see that the chloride on one side is the same as the chloride on the other, so they can be canceled out as spectators. So the overall equation is hydrogen ions, or acid, plus zinc, form zinc ions plus hydrogen gas. The second important type of acid-base reaction is when an acid reacts with a base to form a salt plus water. So here we have hydrochloric acid plus sodium hydroxide, strong acid, strong base. This is going to be a double replacement, so you form NaCl and H2O. Here you have nitric acid and ammonium hydroxide. Again, here you're going to form ammonium nitrate and H2O. And lastly, you have acetic acid and copper oxide, and here you're going to form copper acetate and H2O. So these are called neutralization reactions, and they have a common net ionic equation because everything else cancels. You're going to have H+ plus OH- forming water. The third important type of reaction is when an acid combines with a carbonate to form a salt plus water plus carbon dioxide, because remember we said that H2CO3 always splits apart into water and carbon dioxide. So here we have HCl plus calcium carbonate. Again, double replacement would give us calcium chloride plus hydrogen carbonate, which remember we always write as water plus carbon dioxide. Here we have sulfuric acid plus sodium carbonate, so we'll form sodium sulfate plus hydrogen carbonate, which breaks apart into water and carbon dioxide. And here we have acetic acid plus potassium bicarbonate, and we're going to form potassium acetate and water and carbon dioxide. So the ionic equation, or the net ionic equation for these reactions, everything else will cancel, will always be hydrogen or acid plus carbonate goes to water plus carbon dioxide. And all of these reactions you can tell are making carbon dioxide because they all produce bubbles, which we call effervescence.